Like I always say, it's not what you know, it's what you can prove. So we are bringing you a little bit more proof today. What we're going to be talking about today is more evidence of spherical insanity. Kansas is where? Hank's going to explain that. The focus of today's discussion is what we are sticking to as two pieces of solid information, documented information, to prove we do not live on a spinning damn basketball. Okay? There's no curvature on a flat plane surface. Where we live, work, travel, walk, do all our other business, it's a flat plane. So that we had took a look at and talked about, that is pretty incredible when he presents this information. And then we're all going to readdress the railgun technical capabilities and what it can do.
Another good example I like using is sanitary sewers. When sanitary sewers go in, they got approximately 6 inches of fall over a mile. They can't be put in with too steep of a fall because the waters will leave the solids and the solids will start collecting in the joints of the pipe. So we have to lay it pretty much flat with just ever so slight downhill. Well, when we do that, if we're only given 6 inches in a mile, but there's 8 inches of curve, by the time we get to the half mile, we got a negative 1 inch of flow, meaning that your solids should be standing in your basement.
And you're so right, because I'm a plumber, I can concur with that fall and drop. You have that on every pipe system, wherever it is, because if you haven't got that slope, either if it's too steep, the solids are left behind and the water overtakes it. If it's too shallow, then you just get it stagnant anyway. So it has to be on this set parameter for it dropping from one end to the other. So it carries the solids and everything away.
Exactly. I never gave that thought. You was a plumber. You would understand.
I want John, if he's still in here, we're going to bring up the information on the railgun. So John got that information. I got a document up. I can pull up that document, John. You just show your information and do the share screen, because that's the second piece of information we want to provide with regard to another solid data. We want to go with the railgun because the Navy says they got a railgun that can shoot something from 100 nautical miles. And understand, people, there's a difference between a nautical mile and a regular statute mile. So go for it, Jay.
Pentagon officials believe that this gun could well change the future of military combat. At first glance, the railgun looks like a high-tech naval cannon, but instead of gunpowder to fire this bullet, it uses a magnetic pulse. And it's unlike anything being used in contemporary warfare, requiring a 25 megawatt power plant, enough to power nearly 19,000 homes. The electromagnetic gun catapults a football-sized projectile at Mach 6. That's more than 4,500 miles per hour. Once fired, that projectile becomes the military version of an asteroid, obliterating everything in its path. And unlike conventional bullets, which lose velocity from the moment they're fired, these projectiles gain speed as they go out through the barrel. With a range of up to 125 miles, the railgun can fire a round that would travel from Washington, D.C. to Philadelphia in under 2 minutes.
Yeah, I heard that, right? 125-mile range. But we'll get back to that.
Naval researchers hope that the railgun will not just be a potent offensive weapon, but can also help defend military bases and Navy ships.
Because of our ability to launch these projectiles at great distance and with high accuracy, we're going to actually be able to engage ship to ship again in a way that we haven't in several decades in order to defend the Navy and to carry out its mission of taking other nations out of action and controlling the seas.
Another adaptation? The rounds designed for the railgun can also be used in a host of other weapons, vastly extending their range and power.
You can fire out of naval guns, you can fire out of army guns, you can scale the guns, which provide you an awful lot of different launchers with a very, very deep magazine, of very, very cheap, relatively, rounds, which will allow you to track incoming aircraft or missiles or ballistic missiles, cruise missiles, and potentially shoot them down, like a big shotgun shell.
The Pentagon is putting some $800 million into the railgun and its specialized bullets. The technology could give the US a significant strategic advantage in surface combat against enemy combatants on land and at sea, including Chinese and Russian anti-ship missiles.
They were built a missile at $15 million to target a $15 billion aircraft carrier. Now we're able to defend that carrier at a fraction of the cost of what it costs to build a missile. We have changed the equation back to our advantage.
The interesting part about this weapon is a line-of-sight weapon. It fires a non-self-propelled projectile, basically a bullet, with a range of 125 miles, Robert.
So what you're saying is line of sight. You have to see what it is you're shooting at and aim it at it.
Yeah.
Which means that the 8-inch per square mile is bullshit. Just saw a video, what they said.
Well, this bullet, the projectile contains no explosives. It's just a bullet.
It's just a bullet. That's it. It's just a high energy bullet. That's it.
See, naval railgun. The projectile travels at 5,600 miles per hour. That's Mach 7. You see this thing right here? This is more or less a rifle that fires a bullet. This has a range of 125 miles. It's right here. We showed the video. They even pointed out, they themselves, the ones that designed the railgun, they're showing you a shot from Washington to Philadelphia. What's this number here? 125 miles. So we could put that to bed, right? It doesn't even matter. We can go down to 110 miles or 100 miles. It makes no difference. This is a line-of-sight weapon. We're going to put the railgun 100 feet above sea level. That's right off the deck of a destroyer or a cruiser. And I'm even given the benefit of the doubt with this because I think it's much lower. And according to Mark, it's like 30 or 50 feet. So I'm given 100 feet. So more than enough breathing room here. A target at 125 miles, we can go ahead and pull off the calculator. The distance is 125 miles. The viewer height, or the height of the railgun, is 100 feet above the deck, above sea level. So we're going to calculate again. So the horizon distance is 12.25 miles. The hidden amount is 8,476 feet. The key one here is this bulge height. And like I said, you go down here. This is where the railgun is on the ship. So this bullet has to go from here to the target at 125 miles. It has to ascend and descend at Mach 7. Now, anyone that can fog a mirror knows that this is impossible. I don't know any other way to put it. I can't break this down any further. Let's employ some actual science. The null hypothesis. To do a hypothesis test, you will actually have two hypotheses, the null and the alternative, which are stated in such a way that they are mutually exclusive. Makes sense. The null hypothesis is the conclusion that is considered the default. You will accept this hypothesis if you fail to find sufficient support for the alternative hypothesis, right? So, the null. If the Earth is flat, then shots taken with a line-of-sight weapon, a non-self-propelled projectile, it's a bullet, will not be limited to the Earth's curvature. Bulge and target hidden amount to effectively engage targets for said distance and elevation according to the alleged curvature, which we've just shown. This is the ball earthers hypothesis. They need to validate this. By validating this, they falsify this. Make sense? This is their hypothesis. If the Earth is a sphere with a circumference of 24,901 miles with a radius of 3959, then shots taken with a line-of-sight weapon, it's a non-self-propelled projectile, i.e. bullets, will be limited to the Earth's curvature amount to effectively engage targets. They need to prove this one, validate this hypothesis, whereby falsifying the null. They have to falsify the null. If you can't, then you're finished, scientifically speaking. It's already been validated. They've already said it. It has a range of 125 miles. They've already tested this, as you can see here, for the 1,000th time. The Navy helps to use the railgun for multiple missions, including precision, surface fire support, We'll see that here and again in a second. Land strikes, cruise missile, and ballistic missile defense. The weapon will also be used to fight surface ships. Surface ships are on the surface. This weapon, Dr. Roger McGinnis, he's the executive in charge of the railgun program. The weapon does all of its damage because of its speed. Speed. It can't be an indirect fire weapon because it's a bullet. It has no explosive. See this. The weapon is called a railgun and requires neither gunpowder nor explosive. It is powered by electromagnetic rails that accelerate a hardened projectile, it's about the size of a football, to a staggering velocity. Here it is again. It uses no gunpowder or chemical propellants. You need to carry dangerous explosives on the warship. Here we go again. The 25-pound projectile is a non-explosive bullet. Everyone say it with me. Non-explosive bullet. The incredible speed allows the projectile to strike the target with enough kinetic energy to destroy it with no need for explosives. See that? Now, the naval fire support, we roll down here to naval gunfire characteristics. Naval gunfire has a flat trajectory. As an indirect fire weapon, like artillery, will they use HE or high explosive or incendiary rounds? The Navy railgun projectile is non-explosive. It does all of its damage due to its speed for the 1,000th time. Using it as an indirect fire weapon, the projectile will lose most of its speed and drop a piece of dead 25-pound hunk of metal from the sky. That's really scary, right? I'm sure the Navy's not going to spend $1 billion friggin' dollars to drop 25 pieces of dead metal anywhere. This is tantamount about this. I can't break this down any further.
It's interesting because I want Mark to go ahead and make everyone laugh on the math you did, Mark, with regard to if the rail gun was being fired on a round Earth. Tell everybody where the rail gun would need to be located if it was on a ball.
To go as far as, was it 120, 125 miles? It'd have to be 9,600 feet in elevation to shoot a straight line. And going back to what John was saying about it being, it's the speed that's the key.
Exactly.
If you're shooting something with a 15-degree up angle at Mach 6, Mach 7, whatever it's supposed to be at, it's going to go further than 125 miles.
Exactly.
And that's the key. It's a flat trajectory weapon. It uses that speed to go 125 miles in almost a flat trajectory because it needs that speed in order to go 125 miles in a flat plane. So you can't say that you're going to shoot something at Mach 6 and put a 20-degree up angle on it.
So is it using line of sight targeting then to aim at the ship at 100 miles, which I think they've got this technology to do that. They're either sophisticated pinpoint, cone radar that will actually focus into that point at that distance. So it
all you
doesn't
need is a bearing.